amphipathic compound has a polar and a nonpolar part, and an example of an amphipathic molecule is a fatty acid salt. So we saw fatty acids in previous chapters, and we know that fatty acids have long hydrocarbon chains. We also know that they have a carboxylic acid functional group. When that carboxylic acid hydrogen is removed, then we end up with a carboxylate group, and this carboxylate group has a negative charge. So that's what we mean by a fatty acid salt. The carboxylate group has a negative charge, and there's some other positively charged ion associated with this to keep the charges balanced out or neutral. This is a cartoon representation of a fatty acid salt where we have the polar head, is what it's called, represented with this sphere, and that's the carboxylate group that has a negative charge, and then the nonpolar chain is represented by this long kind of tail, if you will. Soap is composed of fatty acid salts, and this makes, because there are two parts of the molecule, the nonpolar, which is known as hydrophobic, and the polar, which is known as hydrophilic, this allows soap to dissolve stains. So when an amphipathic molecule is in water, what it will do is it will arrange itself so that the polar parts of the molecule interact with water. And what fatty acids do is they form this spherical shape that's known as a micelle. And in a micelle, we have the nonpolar center where all the nonpolar or hydrophobic tails are interacting with one another according to a London force. And then the polar head that has a negative charge is interacting with water in an ion dipole attractive force. So what this nonpolar center can do is it can actually dissolve some grease. So when you apply soap to your skin or to any sort of surface and there's some greasy exterior, the micelle interior will dissolve that grease. And because of the polar exterior of this micelle, it will dissolve in water. And then it can simply be washed down the drain. Amphipathic compounds such as soaps are also known as emulsifiers, and we see this in some food products as well, particularly salad dressing, because they allow nonpolar, such as oil, and polar, such as vinegar compounds, to be suspended in the same mixture.